So this is lesson 6, and we'll be learning using triangle proofs in CPCTC to prove a definition or a converse theorem. So we kind of covered this in lesson 5, however it was a bit much with CPCTC and learning that for the first time, so we're going to do a whole separate lesson just on taking it a step further. So we may be asked to prove some other definition or converse theorem beyond just proving corresponding parts congruent, which again, remember, corresponding parts are sides and angles. So the process is to prove the two triangles are congruent first, and again, the only thing that should go with a triangle congruency statement would be side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse leg. Once we've proven the two triangles congruent, we can then talk about the corresponding parts, or use CPCTC. And those parts that we talk about using CPCTC will demonstrate the definition or the converse theorem exists or is true. So the last statement of the proof in any proof is what you are being asked to prove. And the last reason for the proof when we are going beyond CPCTC will be the definition of or whatever the converse theorem is. So there are a couple things that they may ask you, and we'll talk about more of them after. One thing that you may be asked is to prove that a point is a midpoint of a segment. So we know that a midpoint of a segment is a point that divides a segment into two congruent segments or parts. Okay, so if we look at this diagram here, in order for C to be the midpoint, we have to know that AC and CB are the same. So let's say we had two triangles here, and we weren't given AC and CB were the same. However, we were given other information about the triangles, so we could prove the triangles are congruent. And then from there, use CPCTC to demonstrate that these parts are congruent. And then we can state that C is a midpoint. And again, we'll do an example of these. So in addition to proving that something is a midpoint, you might be asked to prove that a segment is a median. So remember, a median is a segment drawn from one vertex to the median, to the midpoint of the opposite side. So if C is the midpoint, DC, we can prove to be the median. All right, so something closely related to that would be a segment bisector. So the definition of a segment bisector is a line or segment that divides another segment into two congruent parts or segments. All right, so again, if we look at this diagram, if I want to prove that CD is a bisector of segment AB, then again, I would have to show that AC is congruent to CB. And so if I had two triangles that went to this line, I would be able to prove the triangles congruent and then talk about these parts being the same through CPCTC, and then I can prove that this segment must be a segment bisector since it divides AB into two congruent parts. So we're going to look at an example in the next video.